The IS6 integrating spheres have a specified sensitivity to beam size and sensitivity to beam divergence. What's that all about? In order to be able to appreciate that, let's first remember how an integrating sphere works. Here's the basic idea. The inner surface of the sphere is coated with a highly diffuse white coating. The beam enters the sphere through an opening, and because the inner surface is so highly diffuse, the light is reflected multiple times in all directions. This causes the light to be uniformly distributed around the entire inner surface of the sphere, in theory. It's actually subject to a number of technical details and assumptions. Because of the uniform distribution of the light inside the sphere, we can use a power sensor to sample a small part of the sphere's inner surface and measure the power there. Knowing the area of the sensor and the surface area of the sphere, we can automatically apply a traceable calibration factor to get the total power in the sphere. Now back to our divergence angle and beam size. As the divergence angle of the beam entering the integrating sphere increases, and as its diameter increases, the assumptions on which we base the sphere's performance, infinite reflections inside the sphere walls, perfectly uniform distribution of light inside the sphere, become less correct. We therefore specify the maximum beam divergence, such as plus minus 60 degrees, and we also state the maximum possible change in reading caused by change in beam size. In fact, we also state in the datasheet that the maximum additional uncertainty due to beam size is only plus minus 1% for beam divergence less than 30 degrees and plus minus 3% for beam divergence greater than 30 degrees. To give this more meaning, basically, if you measure the power using a beam that's not more than a few millimeters in diameter, that has a relatively small divergence angle, and is centered on the sphere's input port aperture, you can safely ignore this additional uncertainty. To learn more, contact Ophir directly or via your local Ophir representative, or visit our website.